as I'm sure many already know about why practice, it is a part of our why learn program. And as the name suggests, it is a program meant for developing and practicing AI and data skills. So we mean to provide opportunities for women to get in a group setting, and but not only women. We have been always since the beginning of this initiative been inclusive of all genders. So mentors, team members, all genders welcome. And I suppose the strength of why practice lies in the group project work. So there is a strong aspect of teamwork involved. Unlike hackathons, we have a proper project, AI project phasing involved, which resembles more the real workplace situation rather than a hackathon. But as well, in addition to that, we have mentors, coordinators, people who are making sure that the project is run smoothly, that the deadlines are met, and so on. So in that sense, we give people opportunity to practice not only the skills, the technical expertise, but the leadership, mentorship, project management, and the final outcome being something that they can effectively show as part of their portfolio. So, and along the way, of course, make new friendships, make new connections, get to know people from different companies and grow their network. So as an upgrade to why practice this year, we decided to do project presentations. So each project that we build through why practice, the project members will have the opportunity to present that to a wider public and describe how they identify the problem, how they approach the problem, found a solution, and along with along with presenting different technologies and libraries that they used. So let me now move on to introduce our speakers. Today we have Noreen Lenihan, who is a senior data scientist at Pfizer. She works with a team of data scientists who build machine learning models to detect money laundering and prevent financial crimes. Before becoming a data scientist, she worked as a software engineer for both large multinationals and startups. She has lived in several countries, including UK, USA, South Africa, South Korea, and Austria. Wow. And hopes to resume her adventures when the world reopens. Welcome, Noreen. So our second speaker is Bhuvana Ganesh. She is currently doing her PhD in computer science at University College Cork, and she's working on securing data for artificial intelligence using cryptographic tools. She loves trying new areas of science, reading books, and learning new languages. She's also a member of Women in AI Ireland. And our third speaker, Meghna Gatti, she holds a master's in electronic engineering from UCD and is currently working as a data scientist at ABM. Meghna has been involved with Women in AI Ireland, in particular this program, Why Learn and Why Practice, as a coordinator, and she has a strong passion for AI. So now let me give a word to Noreen, who will present her part of the project. There will be an opportunity later on to ask questions. In a Q&A session, questions will be addressed in the order that you sent them, and we will make sure to answer your question. Noreen, the stage is yours.
Thank you so much, Eva. And could I confirm that you guys can see my screen?
Yeah.
Great. Thank you so much. So thank you, Eva, for such a lovely introduction. And yeah, so this is welcome to our presentation, everyone. And so today we're going to talk a bit about the project that we looked at as part of the Women in AI Learn initiative that commenced late last year. And so I had the privilege of working with Bhuvana and Meghna on really a topic of our choice. And what we came up with was to look into some deep learning techniques for detecting COVID in chest X-ray imagery. So I think COVID has kind of infiltrated all our lives at this stage and different aspects of our lives. And, you know, as we brainstormed and tried to come up with an idea for what we could do for this project, you became clear that it would be good to, I guess, understand ourselves a little bit more about COVID, but also our kind of group goal was to improve our image processing and classification skills, because maybe that's not something we would have had much experience in our day-to-day jobs and studies. So it seemed to be a really good fit. So I'm just gonna move on now to the next slide. So Eva has kind of already introduced us, but I guess this is us. So this is the team. And so again, my name is Noreen, and as Eva mentioned, I work in a company called Fiserv. So they're a large fintech, and I work out of the Midwest, so in Neenah County, Tipperary. And so I work with a really great team of data scientists there. We do a whole bunch of things, but in my role, particularly the last year, I've been working with some data scientists to try and detect money laundering activity. And my wider kind of group in the team, they would look at other aspects of different financial crimes, and also things like scraping the dark web for stolen credit cards and liquidity models. So there's a whole bunch of kind of cool and interesting problems going on, and yeah, I'm lucky to kind of work with a great group of people at work, and also and interesting problems. And before transitioning into a career as a data scientist, as Eva mentioned, so I worked as a software engineer for a while, and I felt like that gave me a really good basis and good foundation in programming, which is one of the key kind of, I suppose, aspects in the Holy Trinity that is data science. And so had some good kind of experience as a software engineer, but ultimately I wanted to go down the kind of data science route. And I was lucky enough to go back and do another master's to kind of retrain in machine learning and AI, and then I joined Fiserv. So I've been there for about 2.5 years now and going strong. So I'll pass over to Bhavna now, who will give you a bit of another brief bio.
Thank you so much for that, Noreen. So hi everyone, thank you so much for tuning in today to listen to us talk. I'm Bhuvana Ganesh, and I'm a second year. I work as a security cryptography kind of person there, and because of this. This research group, I'm heavily invested in artificial intelligence, but my bachelor's and master's, which I did in India, were both in mathematics. So I come from a very theoretical background. So practical implementations like programming always intimidated me a little bit. So I joined joined Women in AI, and also this particular project to overcome both of those fears. And these two young ladies, magnificent ladies, actually helped me do that as well. So that's the brief introduction about me, and I'll pass the mic to Meghna.
Thanks, Bhavana. Hi, everyone. I'm Meghna Rathi. Like Eva said, I have a master's from UCD in electronic and computer engineering. So most of my modules were a mix of maths, physics, electronics, and just a tiny bit of computer science. But I realized I really do enjoy coding from the few modules that I had. So when I graduated in 2019, I started my first job in IBM as a technology consultant. And this involved a bit of software development projects. And then I later transitioned into a data scientist role because I really do like, working with AI and analytics. So currently I work with a team where we are trying to use analytics and AI to basically make supply chain processes more efficient, more greener, and just to find novel ways, innovative ways in which we can make transport and logistics operations just more smoother for our clients. I saw Women in AI last year and felt it's a great community for women to meet other professionals in this field. And that was one of my reasons for joining this project, because I not only wanted to enhance my skills in coding and AI, but also learn from Bhavana and Noreen, because they are slightly more experienced in this field. And it was a great experience. I really enjoyed it and definitely learned a lot. So I'll pass it back to Noreen now.
Thanks, Meghna. That's great. So I suppose just to open up with just to go back to kind of where we started on our WayLearn journey. So our project goal really was to, once we decided that we wanted to look into some aspect of COVID and see, how we could apply machine learning techniques to it, we started looking around for, open source data sets. And so we came across a data set by a researcher at the University of Montreal, Joseph Paul Cohen, who was putting together an open database of chest X-ray and CT images for COVID positive or suspected COVID cases. And it seemed like, really kind of meaningful, I suppose, project, and also something that, again, we could kind of wet our feet with in learning, I guess, upskilling our image classification skills. So we wanted to try and see if we could build a classifier to discriminate between COVID positive and non-COVID cases. And I suppose within that kind of distinction, there was, maybe two sub-distinctions, and that was there was COVID, X-ray images out there, but also other pneumonia images. So not just, patients that were still sick. And we wanted to kind of distinguish between COVID and other pneumonia types, but also between COVID and healthy patients. So those were our two kind of sub goals. And I suppose, as we all know, I suppose by now, that the unmatched kind of success of deep learning and CNNs for different types of image tasks, it became clear then that we would, focus our energy on developing CNNs and learning, how best to apply CNNs for this particular use case. So just to tell you a little bit about the data set. Yeah, so as I mentioned, this is an open data set. It's a piece of ongoing work by researchers at University of Montreal, and they're, collecting this data, still today. But it is basically image data scraped from academic papers where hospitals, are actually releasing some of the de-identified data on chest X-ray imagery and also CT. And I suppose one of the things to highlight here is that, even in their research, and they're full-time, I suppose, kind of medical imaging researchers, they're not kind of, prescribing this X-ray imagery, as a sole diagnostic tool for COVID, but it's just something that we could use to help understand and predict, I suppose, the severity maybe of the infection a bit better, and probably give some, I suppose, credence to different prognostic and assessment tools. So more so maybe predicting if the patient will need, supplemental oxygen or intubation or things like that, rather than purely as a diagnostic measure. And I think the CDC have kind of re-emphasized that again. So right now we obviously rely on the PCR, I think, kits for diagnosing COVID, but it's not, recommended to use such things as X-rays or CTs, on their own for that diagnosis. And so this data set, at the time that we were working on it, contained 950 images, so chest X-ray and CT, but we just took the X-ray component because at that time there wasn't many CT images. And so among those images, then there are different kind of views. So there is the posterior anterior, the anterior posterior, and supine views. And as Bhavna will describe it in a few minutes, we just use the PA views because I think that is kind of the recommended approach in different papers that we looked at. And there was also the most prevalence of PA across different patients. And so the data set itself, then, it had also metadata associated with it, so in the form of kind of numeric data set. And so you can see an overview of it here. And we initially thought we could build, another classifier based on this data and see, what would its potential be in distinguishing between COVID and non-COVID. But unfortunately, as you can see here, there is a lot of missing data for different, attributes, and some of these would be interesting clinically relevant attributes. But due to the levels of missing data, it just wasn't feasible at this stage, I suppose, of data collection. So just moving on then to the outcome labels. So I suppose this is a supervised classification task. So we relied heavily on the labels, and in the data set, these were the types of labels available to us. So we can see at the top that there's 584 cases of COVID-19 positive. And then there's a lot of kind of missing data, so to-dos, unknowns, no findings that we would have eliminated. And then there's also, you know, a whole host of other different types of pneumonia. And so they would have formed the kind of bucket of non-COVID cases, but still other pneumonia types on which we would have built a classifier for as well. And so I suppose because this data set is collected really just by scraping academic papers from all over the world, you know, it is very biased in that sense. So really, we're looking at the breakdown of gender here, but I suppose just keep in mind that it's a very biased data set, and we're just kind of presenting what the proportions, you know, are in the data set that was collected, you know, not saying that it is representative of COVID itself in the population. But we can see here that in the data set, you know, there is a slightly higher proportion of males overall, you know, that we have images for, but also that males, slightly higher proportion of the COVID positive cases are male. And in terms of the age distribution, again, it is a biased data set, but we can see here, so we're looking at the COVID in orange and the non-COVID in blue, and there is a slightly higher, I suppose, shift, you know, to the right in terms of patient age for those that are COVID positive. So I think overall the mean for the non-COVID patients in the data set was around 47 years of age, and for COVID positive it was something like 58 years. So kind of slightly higher age profile for that patient, for those patients. And again, I suppose that, you know, the idea, you know, for wider research groups, you know, not us, we're purely, you know, did this exercise for kind of exploration and learning, but I suppose groups that are involved in this kind of work, you know, the applications and the wider goal of this is to almost have a digital second opinion. And so that's really what, you know, I suppose the aim of developing machine learning and applying it to these types of imagery is that it can, you know, it can supplement and complement kind of a medical team's, you know, their assessment toolkit, and not to replace it, because, you know, it would be quite, I suppose, hazardous to do that. And we always need clinical studies to go along with these kind of things. But that, you know, I suppose even when medical teams, you know, they take the Hippocratic Oath, I think also, you know, there's an onus on data science teams when they undertake this work to take, you know, similar kind of oath, and that when it is such a high stakes environment, to make clear that this isn't, you know, should never be used probably alone as a diagnostic tool, and to always kind of, you know, to supplement a clinical workflow. So that's kind of my piece, just to show you guys about the data set that we used. And now I'll hand over to Bhavna, who will take you through the different CNNs we built.
Thank you so much for the introduction, Noreen. As Noreen explained, this was about the entire data set and the metadata. And also, as she mentioned, we tried to implement a machine learning algorithm for classification with the metadata, but we had a lot of missing data, so it wouldn't have been possible. We also wanted to do something about survival. So looking at the chest X-ray, can you say if the person survived or not? But that also did not have that much data. So we left both of those approaches, and we concentrated on using artificial neural networks to solve the problem. The first case that we took was between COVID images and non-COVID images. The normal images were taken from another data set from another researcher called Paul Mooney, and he had worked on this data set 3 years back with pneumonia images. So as you can see on top, that's an X-ray of a normal person, a person who is not affected by pneumonia or COVID or anything like that. But in the bottom, you can see from our data set, from the Cohen data set, that this person is actually COVID positive. Can the CNN distinguish between these two? Let's see. So we take equal amount of images between the two. We have about 400 COVID positive images if we consider only the PA view. So we take those images and shuffle them up to form the train, test, and validation sets, which is about split in an 80-20 ratio. We set the parameters as given, and then we run a VGG16 network on these with ImageNet in order to improve the accuracy of the model. On training the model, we find out that it gives really good accuracy, and that even though it's not possible for the human eye to distinguish between those two X-rays, the computer can do it very efficiently with about 98% accuracy. in the of course for the data and the validation set. So this is really good, and we thought that we could apply the same model for our COVID versus non-COVID images to see if the classification is as efficient and possible. Next slide, please, Lorraine. So now we have the COVID, non-COVID from the same data set from Cohen as explained with the majority. And we had 392 versus 296, not exactly equal, but very good. These non-COVID, what were only active.
Bhuvana, you'll have to repeat the last section. We have some connection issues.
These parameters. Okay. So the variables. Hello.
Yeah, we can hear you. Try turning off your camera, maybe.
Can you hear me now?
Yeah.
Yeah, thank you. Sorry for the delay. Really sorry. So I wanted to talk about the classification between COVID and non-COVID lung images, lung-related diseases. We had a disparity between the number of images, but this was okay because we had images between COVID and non-COVID, which were termed pneumonia or bacterial viral. We ran it with the parameters that are mentioned here, including the optimizer and that's the same ImageNet along with the VGG16 model. So essentially almost a very similar setup to what we saw for the COVID versus normal images. Next slide, please. But we see evidently that it was not able to perform that well. We achieved about 60 to 64% accuracy. So obviously we tried to improve our parameters by substituting for different epochs. We ran for 10 epochs, 20 epochs. It wasn't improving at all. And then we switched to ResNet, but still there was no improvement shown in the results. The validation and the loss were not matching at all for the validation set, and the model did not perform well. So also we tried to visualize between the layers a little bit to see what exactly was going on with the convolutions, and we see that after layer 5, we were getting all blacked out images which were not able to concentrate on any of the features. So this was not regular. So we wanted to, but actually the difference 60 to 64 lies because of the randomization process. If we did not randomize the data, we weren't able to get a higher accuracy. So we wanted to know why our model wasn't performing properly. Is it because of groups trying to execute code and it's not working properly, or was it because of the itself and the images? So we needed a look into the explainability section, so a couple of explainability libraries in order to find the reason.
Thanks, Bhavana. So yeah, once we had our data processed, the models built, and we could see the results, we just wanted to basically see what was going on inside the model. So when building complex models, it's often difficult to explain why the model should be trusted, while global measures such as accuracy are useful, they cannot be used for explaining why a model made like a specific prediction or classification. So LIME is a method for explaining the outcome of black box models by fitting a local model around the point in question. It stands for Local Interpretable Model Agnostic Explanations. It's a Python library. It's a library which is rich in features for exploring why neural networks make certain decisions. So when classifying images, we are interested in seeing the areas that support or contradict a classification. And there's a method in LIME which will take the result of an image explanation and highlight the areas found relevant to each label in the explanation. So the highlighting can either be done by blocking the parts of the image that are not related to the classification, or by encircling and coloring the areas that do influence the explanation. We can see the highlighted regions of the image that support a COVID positive classification are like with the yellow boundaries, and conversely that the ones that are opposing the positive classification are the red shaded areas. So this way we could see in what part of the X-ray image of the lung is it picking out like the COVID pneumonia aspects. Next slide, please, Noreen. So another way we decided to look into explainability was by activation maps. They are a great way to see what your convolutional neural network models are seeing while they are training, and offers insights into to the developer as well as like the stakeholders, which can be very crucial to the model's usability and life cycle. So by the help of activation maps, the developers, so we could see which region in the image the model was looking at, and can be used to like examine the reasons for bias in the model, or lack of generalizing power, or many other reasons which can be fixed, and then that would make the model more robust and deployable in the real world. So in the images on the right, we can see like all the feature maps that essentially capture the result of applying filters to the input image. This was very useful because you can see in some of the images, the lungs are very clearly highlighted, and in some it's specific parts of the lungs that are very highlighted. And we can see, okay, the model is actually seeing these things, and this is why it's able to say whether someone has COVID positive, or if they're like normal, no pneumonia. But then what we also noticed was in the case of COVID versus non-COVID, so COVID pneumonia versus non-COVID pneumonia, because pneumonia in general in the lungs looks very similar, that's why the model could not go above the 60-64% accuracy, because you would need like more parameters to be able to say, okay, this pneumonia is due to COVID-19, not like another virus or bacteria. So this brings us to our conclusions. Next slide, please. So what we saw in the end after completing our project was chest x-rays alone aren't enough to detect COVID-19. They can tell you whether you have a certain type of pneumonia or whether you don't have pneumonia at all, but for which particular type you would need to do like more tests. You can't just rely on x-ray imagery. Our sample size, although we had 950 images, we did have 3 different views, and we ended up using the PA view. So that did reduce our sample size, and we just thought it just wasn't enough to, really get a well-trained model. More sources would be required. Randomizing was very important. Before we shuffled the data, the result, we were getting results, but just after shuffling, we could see like there was a good bit of improvement. So randomizing was quite helpful. And then lastly, 2 things, if we had more time, we would look into other tools for explainability and other ways to analyze medical data. This was our first time kind of looking into how to use explainability libraries. So Lime was one library, and the activation maps were using the Keras library. So we tried to use the 2 most popular ones. We would like to see if there's like any other libraries out there that are quite useful as well for like image like convolutional network image classification explainability. And you can find our code on our GitHub page, which we have the link for here. And that was it. Thank you very much.
Fascinating. Very well done. Thank you, ladies. So Noreen, Bhuvana, and Meghna, that was a great presentation. And well done. Congratulations on completing your first project with Women in AI Ireland. And yeah, so this is our first showcase. You were the first to kick off this showcase. And I personally, on behalf of Women in AI, wish to continue following your great work and everything that you do in this AI space. Do we have any questions for our speakers?
Hi, can you hear me?
Yes. Thank you.
Hi, it's not really a question, but I think this is really brilliant, and I think you know, I'd strongly encourage you to advertise it and make as much promotion of it as possible. It's really brilliant, and the presentations were also really excellent, because quite often in this kind of material, people try to. I think people actually try to confuse the audience, whereas you just explained it really, really crystal clearly. So no, thank you very much. It's the best talks I've heard in a while now. Thank you.
Thank you so
Thank
much.
you.
Thank you very much.
Okay, so what we're going to do is we're going to show you the blog that our speakers put together a blog. This is also going to be a recorded session, so you'll be able to go back and see if you missed some parts of it. And as well, let me then continue to thank all the contributors who brought together this this program. And so first of all, big thanks to our ambassador, Alessandra Sala, our great supporter and advocate since the beginning of Women in AI Ireland, Nabanita Roy, who is a YLearn lead, Begum Genç, who is behind the scenes of all the event organization here, Claudia Ekbrude, project managers and coordinators Toju, Duke, Swati, Ishwarya, Lucia Azubuike. Megana is also one of our project coordinators. So thank you, Megana, for helping us all bring this initiative to our community. Just to give you an example of other topics that are currently being worked on, we have other groups working on machine learning to predict seismic bumps, QA chatbot using Facebook Babi dataset, female employment data analysis, and more. All of these you can find in our GitHub. And if you wish to participate yourself, our project, data and AI projects are based on bi-monthly basis. So we don't have hard specified dates for them, but they begin and close in the 2-month frames. So follow us on our channels. The next one will appear around end of March, and other projects. So all the participants who are building projects with us, some of them will present their projects, some of them will not. Keep an eye on the topic, something that is interesting to you. If you want to mentor people in one of the projects, if you want to suggest your own project, that is the best way. If you have something to share, some knowledge to contribute to the community and meet new people, of course, I think it's a great opportunity during this quarantine time to actually cross work with somebody outside your own organization. And so we have a small poll just to check the quality of our events. Begum, if you want to share the link to the audience, just to give us a bit of feedback so that we can improve the way we run our events. And in the closing section, I want to thank everybody who attended this session today, and keep an eye out for the next event, which is going to be International Women's Day. We're preparing a lot. It's going to be a partnership with Microsoft and Dreamspace on the 8th of March. So as soon as the registration are out, go and register. Thanks everybody, thanks our speakers and audience and the supporters. And this was our first session delivered to you, and hope to see you again in the following sessions. Thank you everybody.
Thank you guys, that was very good. Thank you.
Well done, well done.
Thank you. Great job, thank you.